In this screencast, we discuss back-of-the-envelope estimation. Consider the following questions. How many gallons of water does a person use over the course of a lifetime to wash their clothing? Or how much land is required to raise the beef cattle that I or you consume? How many tons of solid waste are disposed of each year in the U.S.? Or how many tons of carbon dioxide are emitted each year from driving a gasoline-powered car? Or how many years of a person's lifetime are spent watching videos or television? Although these questions are fairly easy to state, answering them is more complicated. All of these questions involve variables that need to be considered. The amount of water a person uses, the amount of beef a person consumes, the amount of solid waste generated by a person, the driving habits of a person, and the type of transportation a person uses are all variable. Additionally, some of these variables change over time. For example, because the size of the U.S. population has been growing, we would expect the amount of solid waste disposed of annually to possibly change over time. If we were doing a formal study to answer questions like those above, we would need to address these complicating variables. It's frequently helpful, however, to obtain initial estimates that give a sense for the scale, in other words, the rough size of an answer. These estimates are fairly simple in their calculation and are informally called back-of-the-envelope estimates or plausible estimates. To obtain these estimates, we typically need to know a few key pieces of information, or we may need to make some informed guesses, what we might also call assumptions, and we need some conversion factors. Furthermore, the key pieces of information that we learned in the unit conversion process will actually help us determine these estimates. Consider example 3.12. Estimate the gallons of fluid milk a person living in the U.S. consumes over their lifetime. By fluid milk, let's assume that we're talking about milk that is drunk directly or consumed with cereal or coffee. So in other words, we're not including milk that might be used for processing cheese or yogurt or other dairy items. We're restricting ourselves in this example to milk that we would drink in some form. So that's what it is that we want to estimate. Gallons of milk consumed over a lifetime. This is an example of making a back-of-the-envelope estimate. To do this, we're going to use a 5-step process, and we're going to introduce it through the various parts of this example. So let's start by looking at Part A. Part A will end up being step 1 of this process. The units of the quantity we are estimating are gallons per lifetime. Go ahead and express these units as a fraction, just as you did earlier in this chapter. So we want to write gallons per lifetime as a fraction. We've done that before. We write gallons over lifetime. Okay, that's what it is that we're trying to estimate. Now let's look at Part B. Let's suppose that an average person consumes a cup of fluid milk per day and that the life expectancy of an average person is about 75 years. Express these two pieces of information as fractions. So in this step of the process, what we are doing is thinking about what information we would need to know in order to make an estimate for the gallons of milk consumed over a lifetime. It seems reasonable, if we want to make this estimate, that we would need to make some kind of an assumption or have some kind of information about how much milk a person drinks, maybe each year or each day. In this case, we're making an assumption that a person drinks a cup of milk a day. And if we're talking about how much they drink over a lifetime, then we're going to need to say something about how long a lifetime is. So in this part of the back of the envelope estimation process, we're writing down the information we believe we would need to know. And again, we're going to write this down in fraction form. So we've got 1 cup of milk consumed per 1 day, and we've got 75 years per 1 lifetime. Now let's go ahead and look at part C. Now imagine that you are performing a unit conversion. The desired units are gallons per lifetime. In other words, our answer in part A. The 2 fractions in part B, these 2, will be involved in the unit conversion process. But you will need some additional conversion factors too. Write down the conversion factors that you think you will need to know. So again, imagine that we were doing a unit conversion and these are the desired units, these are the given units. So the question here really is, what conversion factors do you need to multiply these 2 quantities by in order to obtain these units after you've done the conversion? Well, let's think about this for a minute. If we look at the units that we desire, we have gallons, but we do not have gallons in any of our given information. Instead, we have cups. Now, we can go from cups to gallons, but some of you may not know how to go from cups to gallons directly, so we can do this in a couple of steps. Here's one conversion factor that you might know. There are 4 cups in 1 quart, and another conversion factor is that there are 4 quarts in 1 gallon. So these 2 conversion factors here should enable us to go from cups to gallons. Okay, now we have lifetime in our desired units and we have lifetime in our given units, so we don't need to do anything to get rid of that unit. The only other thing we need to address is that some of our information is given in days, some of it is given in years, so we need to be able to convert from days to years, and we can do that with a single conversion factor because we know that there are 365 days in 1 year. Okay, so let's move on to the next part of this. Part D. Shown below is the first part of an equation. The left side contains the desired units. That's right here. These are the units we're trying to get. The right side will ultimately be a product of our information, that's this information, and our conversion factors, that's these, or possibly their reciprocals. Go ahead and finish the right-hand side of the equation so that both sides of the equation have the same units after you've canceled common units. Okay, so notice on the left side of the equation we have gallons per lifetime. That's what we're trying to estimate. On the right side of the equation, the first fraction has been given to us. And notice it's 1 gallon per 4 quarts. It's precisely the reciprocal of one of our conversion factors right here. Why did we need to take the reciprocal? of this fraction? Well, because the left side of the equation has gallons in the numerator, so we know on the right side we need gallons in the numerator as well. So that means we need to take the reciprocal of this fraction. Okay, if we look at what we've got, the left side is gallons per lifetime. Currently, the right-hand side is gallons per quart. So the units on the left side of the equation do not match the units on the right side. So that tells us we need to multiply by another fraction that will eliminate the quarts units in the denominator. So we go back up to all of the information we've got and we look for another fraction that involves quarts. We don't want to use this one because this one was just used right here. We need to find another one, and this one here works. Notice this fraction has quart in the denominator. We need a fraction that has quart in the numerator, enabling us to cancel the quarts here. So we're going to take the reciprocal of this fraction. So I'm going to write 1 quart per 4 cups. And in so doing, I cancel the quarts. Now the units on the right side are gallons per cup, which still does not match the units on the left side. That tells us we need to multiply by another fraction. We need a fraction that will cancel cups. So we go back up to our information and we look for a fraction that involves cups. We have it right here, 1 cup per 1 day. So I'm going to put in 1 cup per 1 day. And notice I don't want to take the reciprocal of this fraction because I already have cups in the denominator and I need cups in the numerator to cancel it. Now the units on the right side after canceling are gallons per day, which still do not match the units on the left. That tells us we're not done. We need to multiply by something else. We have to go back up to our given information and find yet another fraction that involves days. And this one will do it. So we multiply by 365 days per 1 year, and this will enable us to cancel out days. And now the units on the right side after canceling are gallons per year, which is still not what we need, but we're getting closer. We need to go back up to our information here and find something that has years, and this fraction here will do it. So we can go ahead and we multiply by 75 years per 1 lifetime. And notice that the years in the numerator cancel the years in the denominator, and now after canceling, the units on the right side of the equation are gallons per lifetime, which matches the units on the left side. And that signals to us that we have completed this calculation. So now that we've figured out what the calculation is, we actually need to work out numerically what the estimate is. So we will take the 1 times the 1 times the 1 times the 365 times the 75, calculate that, and divide by the 4 times 4 times 1 times 1 times 1. After we do that, we will arrive at an answer that is, and I'm going to use our approximation symbol here, we're going to arrive at an answer that is approximately 1,700 gallons. And this is gallons per lifetime. Okay, so that's our estimate. The last step in this estimation process is to actually communicate your estimate. And we always have to be careful about how we communicate estimates, because there are almost always some assumptions or some educated guesses that we made in order to arrive at our estimate. So when we communicate our estimate, we always also communicate the assumptions that we used to make that estimate. So let's look at part E. Write down 1 to 2 sentences summarizing your answer and the assumptions that were used to obtain your estimate. So let's write down what we've learned. We can say that if a person drinks an average of 1 cup of milk each day, and they live for 75 years, then they will have consumed about 1,700 gallons over their life. So that's how we might communicate this publicly. Okay, let's take a look at the last part here. So why would it have been wrong to start the right side of the equation above with 4 quarts per gallon? So this is just a recap to make sure you understand how the right side got started. This fraction was provided for you, and the question in part F is really getting at the following. Suppose we had gallons per lifetime. Suppose that was the left side, which it is right there. Why would it have been wrong to start the right-hand side with the reciprocal, 4 quarts per 1 gallon? After all, this conversion factor is just the conversion factor that we had up here. Why couldn't we have started the right-hand side with this conversion factor when up here you can see we started with the reciprocal? And the answer to this question is that if you look at the left side here, gallons is in the numerator. If gallons is in the numerator on the left side of the equation, gallons has to be in the numerator on the right side of the equation, and you can see it's in the denominator here. So if you started with quarts over gallons and you finished the whole calculation performing all these multiplications, in the end the right side of your equation would have ended up being lifetime per gallon instead of gallons per lifetime. So in other words, the left side of your equation and the right side of your equation would be measuring very different things when you finished. So always remember, the units on the left side of an equation have to match the units on the right. If gallons is in the numerator on the left, it's got to be in the numerator on the right side of the equation. The last example illustrates how the unit conversion process can be adapted to make back-of-the-envelope estimates. The box on this page summarizes the 5-step process that we use to obtain our estimate. We're going to again use this process in our next example. Example 3.13. Use the 5-step method to estimate the cost of running a laptop computer over the course of a year. Suppose that the cost of electricity is approximately 7 cents per kilowatt hour and that the power draw for a laptop is approximately 50 watts. You will need to make an informed guess about the amount of time a laptop is typically turned on. Give your final answer in dollars per year. So, our goal is to estimate the cost of running a laptop computer over the course of a year. That's our final goal, and we have to remember not to lose sight of that. So let's look at step 1. Determine the units of the quantity being estimated and express the units in fraction form. Well, in this case, we're told to give our answer in dollars per year. So those are the units we're looking for. If we write it in fraction form, it's dollars over year. So those are the desired units. That's what we're striving to get. Now let's look at step 2. List all of the needed information. This is the information we believe we would need to know in order to make this estimate. Go ahead and express the units in fraction form wherever appropriate. Well, let's go back and look at the information we were given. There's an assumption. Suppose that the cost of electricity is approximately 7 cents per kilowatt hour. That is an assumption or an educated guess, but that is one of the pieces we think we ought to know in order to estimate the annual cost. So if I write this down in fraction form, it would be 7 cents per 1 kilowatt, and I'm going to write this as kilowatt times hours, because remember, a kilowatt hour is the product of a certain number of kilowatts and a certain number of hours. What else do we know? We know that the power draw for laptops is approximately 50 watts. So we've got 50 watts. And this is 50 watts for one computer. So you could say per computer, but everything in this problem is really per computer. We're not making an estimate about 1,000 computers. This is just one computer. So we can just say 50 watts. And if we want to write this as a fraction, we can just say 50 watts over 1. Now, do we need to know anything else? It says up here you will need to make an informed guess about the amount of time a laptop is typically turned on. That would make sense because the longer a laptop runs, the more electricity you use and the more you would pay for that electricity. So we'll need to make some kind of educated guess about how long a computer is turned on. Most of us might be thinking in terms of how long we would have a computer turned on each day. So perhaps you might say 10 hours a day. So let's just make an assumption. You might choose a different assumption. But we'll say that the laptop is turned on for 10 hours every day, or per one day. Again, you might have chosen 20 hours. Maybe your laptop is always turned on, or maybe your laptop only runs 5 hours a day. So you might choose something different than what I have written here. Okay, let's look at step 3. Next, we need to list all of the conversion factors that we think we will need to know in order to make this estimate. So what we need to think about is if these are the given pieces of information, and these are the given units. What conversion factors do we need to multiply these by in order to arrive at our desired units, which would be dollars per year? So we need to take a hard look at the units we've got and think about how we're going to arrive at these units from these units. Well, first of all, notice that our answer is in units of years, but we do not have anything in units of years here. Instead, we have one piece of information that is given in a per day format. So we are going to have to convert from days to years, and we can do that with one simple conversion factor. We know that there are 365 days in 1 year. So that conversion factor should be enough to get us from days to years. Another thing to look at is the fact that our information is given in units of cents, but our final answer has to be given in units of dollars. So we're going to need to convert from cents to dollars. We can do that again with a simple conversion factor, namely 100 cents per $1. Okay. Finally, if we look at our given units here, notice that some of the units are given in watts and others are given in kilowatts. So we're going to need to convert between watts and kilowatts. And we know that there are 1,000 watts in 1 kilowatt, or said another way, there are 10 to the third watts in 1 kilowatt. So these three conversion factors should be what we need to multiply our given information by in order to calculate the desired estimate. Okay, now let's move to step 4. We need to write down an equation. On the left side of the equation, we're going to write down the desired units from step 1, and on the right side of the equation, we're going to multiply the known information, or possibly their reciprocals, and the conversion factors or their reciprocals. After canceling all common units in the numerators and denominators on the right side of the equation, you should be left with an equation where the units on the left are the same as the units on the right. So let's try this out. On the left side of the equation, we should have the desired units. For this estimate, the desired units are dollars per year. On the right side of the equation, we are going to be multiplying all of those fractions that we wrote down in steps 2 and 3. So how do we start? Getting started is the hardest part. One way to help you get started is to look at what unit appears in the numerator on the left side. It's dollars. So let's start with dollars. Go to steps 2 and 3 and find a fraction that involves dollars. And you'll see that you have a fraction, 100 cents per $1. That's the fraction we'll start with. Now we need dollars in the numerator, but our fraction, 100 cents per $1, that has dollars in the denominator. So we're going to have to work with the reciprocal. So we're going to have $1 per 100 cents. Writing the reciprocal gives us dollar in the numerator on both sides. This gives us a good start. Now, we're going to have to multiply this by another one of our fractions. We know our final answer should not have cents in the denominator, so we need a fraction here that will cancel out cents. So go back to steps 2 and 3 and find yet another fraction that involves cents. In this example, you'll see that you have 7 cents per 1 kilowatt hour. So that's the next fraction we multiply by. 7 cents per 1 kilowatt hour. And notice the cents cancel. So now let's take care of the hours. We have hours in the denominator. We should be having years in the denominator. So we're going to need to convert from hours to years. So first of all, let's find a fraction in steps 2 and 3 that involve hours. You can see that the fraction 10 hours per 1 day, that was our assumption for the amount of time the laptop was turned on. That's the fraction we need. So we have 10 hours per 1 day. Multiplying by this will cancel out the hours, and now we have units of days in our denominator as opposed to years. So we need to convert from days to years. But we have a conversion factor in step 3 that does that, namely 365 days per 1 year. And when we multiply by this, you can see that the days cancel, and now we have years in the denominator, which is what we wanted. So let's take a look at the right-hand side for a minute. What units are remaining? We've got dollars in the numerator, which is what we wanted. We have years in the denominator, which is again what we wanted. The only thing we have to take care of yet is the fact that we still have kilowatts in the denominator. They need to be canceled. So let's look for a fraction in steps 2 or 3 that involve kilowatts. And you see that we have a conversion factor that we can multiply by, namely 1 kilowatt per 10 to the third, or 1,000 watts. So when I multiply by this fraction, notice the kilowatts cancel, but now we're left with units of watts in the denominator, which we didn't want either. So now we go back to steps 2 and 3 and we locate a fraction that involves watts. Well, there's only one fraction we haven't used yet. It's the 50 watts over 1. So we're going to multiply this by our 50 watts over 1. And when we do this, the watts cancel. And now our units, after all the canceling has been done, the units on the right side of the equation are dollars per year, and it matches the units on the left side. Now, to work out our estimate, we have to multiply the numerators together and then divide by the product in the denominator. So we'll have to multiply the 100, the 1, the 1, the 1, the 1,000, and the 1. So work those products out and then divide, and in the end you should arrive at an estimate that is about $13 per year. So that's our estimate for how much money we would spend running a laptop for a year if we had it turned on 10 hours a day and if the electricity cost 7 cents per kilowatt hour. So let's proceed to step 5, and step 5 is where we actually communicate what we found in a sentence form. So We want to explain what we estimated and what assumptions we made in order to obtain this estimate. So we can write the following. So if a person runs a 50-watt laptop for 10 hours a day and pays 7 cents per kilowatt hour for electricity, then over the course of a year, the person would pay approximately $13 to run the laptop. And that would be how we would communicate this estimate.